So let me go to Wayne now. Wayne, so Wayne did some Alzofon testing. Wayne, go for it, sir.
Yeah, hi, can you hear me?
Mm-hmm. Yeah, and if you want to do a screen share, you can do the videos that way.
Actually, I was wondering if you might be able to do that. I just don't want to. I sent you a link in WhatsApp there.
Yeah.
To your personal.
Well, let me see. Yeah, let me find that.
Okay.
Oops. And I'm not sure. Oh, that's on YouTube. Hang on.
I just wanted to say, Jeremy's presentation, I only caught some of it, but it was great. And as soon as I turned it on, it's like he's talking about lasers. I'm like, that's exactly right. And there's actually research that's been done, published papers and stuff that have proven that light and electromagnetic energy does actually create something like a gravity field with a Cavendish type setup. And there's a few papers that go into that and prove it.
Okay, well, so Wayne, let me do this. So I've got you pinned, so it should show you. What I'm going to do now is share screen. And hey, hang on just a sec. Sorry.
Yeah. So let me just say. So this was first of all, this is a couple things. So the reason Mark and we kind of got like working together. It was around the Alzofon experiment that kind of brought us together. Just for people who don't know much about me or kind of the background. So for me going there and visiting and working on his setup was an interesting experience. And so there's actually, I had probably a couple hours of footage, and I had to sort of chop it up quite a bit, and it's a big job. So what you're loading up there is sort of an introduction, just kind of like an overview.
Yeah.
For some of the people in the audience, it might be kind of redundant, but I don't know how many newer viewers there are here today, so they might find it helpful. So it is it's like an introduction, just kind of an overview of the setup and the and I just kind of like introduced the process, like of how so I tested a number of different samples, but they won't be shown in this video, like all the different samples. I'm still editing those videos and putting them up on my channel. So I've done a couple so far. So I'll continue to put them up over the next few days as I'm able to keep editing.
Okay. Do you want me to press play now, Wayne, or?
Yeah, sure. Go ahead.
Okay.
Looks like you're missing audio.
Sorry about that. Give me just a sec. Where's my window at? Sorry, my window disappeared.
Drew in sunny Florida. That sounds pretty interesting. Do you have a website, or are you new here, or have you been on APEC before?
Yeah, I've been popping on and off this thing for a while. And no, we don't have a website. No, there's nothing published. Although our patent is now issued, so you can go out there and read that. It's 87 pages of amazing. But if you get through it, let me know, because we might want to hire you, because we haven't found anybody yet that can read it aside from the guys who wrote it. So I don't know exactly how to answer the question, but somebody asked if this is some kind of
find it.
the patent,
Yeah.
just Google my name, and it'll pop up for on the
Okay.
patents.
Sorry, guys. Let me share this again, and I'm going to max out the volume there.
And this amplifier got
What kind of power?
259 hours on it right now.
What kind of power level are you putting in there right now?
Very low power. You got to be very careful not to destroy this thing because it can't take more than 1 watt. Plus 30 dBm. Right now we're at negative 16. We can go up in the power. Now we're pretty strong.
977, couple milligrams.
Here, these are like the fine-tune adjustments.
Frequency adjust?
No, this is magnetic field adjust. You see how the Gauss is changing over there?
Gotcha.
So what we're doing is we're testing a little aluminum
Should
pellet.
never go above plus
Just
30
pure aluminum?
dBm, but this is here to protect it. Hopefully it works well.
Okay.
I need to give him a ride. Okay?
Small changes happen here on the milligram level. There's our frequency 9.425 gigahertz. So I'll be playing with this a little bit here and see if I can make something happen there. Trying to get it up to 3363 as per the calculated more frequency. The RF is currently off. So what I'm doing is just watching this weight here. A little aluminum pellet is inside this hole here, suspended on the fishing line. It's very pure aluminum. So I'm just looking for any weight changes just from just the magnetic field, and this would be a very parallel field here, because this is an electromagnet for EPR machines, electron paramagnetic resonance machines, for doing spectroscopy. So this is the Faraday cage here that they built. And in here is the experimental machine. This is the electromagnet. It weighs a friggin' ton. And down here is this is the microwave waveguide here and some components. This is a circulator. This is an isolator to protect the equipment. And down there you can see the hole and the aluminum pellet is just inside there. And then this fishing line goes up to the bottom of this analytical balance up top here, and which goes into the computer. So this might be worth noting. Here. What I've done is I've located, it looks like the resonant frequency of the hole in the, right here, the resonant frequency right here in this hole, like where the waves tend to, I guess there must be some sort of node there, because when I put a metal object in there, there's a slight decrease in the attenuation of the signal generator. So that tells me that that's where the wave is, there must be a node there, so the power is being, it's not being lost there. So if I move this frequency a little bit, okay, I'm going to remove the little piece of aluminum out of the hole, and I think that little dash there will meet at this line with a diamond, meaning that there's a change in the reflected power. Yeah, so I removed the little piece of aluminum out of the hole. See that
This is
little
something
node
that
there as a
special feature all noted
See, I
as being
took it
important
out
that
of
you
the
find
hole
that
there.
little, flip, the little dip there on the screen.
So if I find where this is here, if I line that up, you see how that diamond appears? So there's a change in the reflected power. 9.4233 gigahertz. So also note the electromagnet. The electromagnet is off. Basically, that's pretty much off. And so this is what the situation is. Here. So what I'll do is dial up the electromagnet. I'll put the aluminum rod, the aluminum pellet back in there, and then dial up the electromagnet. And see if there's any change on this peak here. Okay, so after inserting the pellet back into the hole, this spike has now gone up higher, indicating a change in reflected power. So now we'll turn the electromagnet up, and that's read 9.4233 gigahertz. So I'll try and find the resonant frequency. Magnetic probe is right on the surface of the electromagnet pole, so I'm just wondering if that's going to... This other meter shows about 3850, measured right by the sample there and right on the pole. So there's a discrepancy here between what this meter is saying. The meter that's in there is saying 3355. This one is saying 38. That's a difference of 500 Gauss. So this is showing that measuring right on the pole, versus measuring right beside the sample there in the middle is approximately the same, give or take a couple of tens of Gauss. So it's pretty close. So it shows the field is quite uniform. The field is quite uniform across here. There's a little bit of variation. But I'm going to try this meter here, this Tesla meter, to see if I get something similar. About 3,900 Gauss on this meter, and the other meter is about the same, 3,800, 3,900. So I'm suspecting this Gauss meter here is way off. And so this is what I've been going by. So I've been out by 500 Gauss. So that might explain why I'm so far, maybe might explain why I'm having trouble seeing anything here. So I gotta turn this down, find the resonant frequency. 9.42 I believe is at just gotta double check my calculation. So I've been playing with these dials for a long time, trying to very carefully dial in the precise frequency and magnetic field necessary to see some kind of absorption here on this spike. So I'm using the same little pellet of aluminum in the hole there, but I'm not seeing any absorption here with magnetic field. So I think what's happening is it's just reflecting off the surface of the pellet because it is solid metal. So I might try a different sample, like a powder or a just chips, aluminum or copper or something else. I think what's happening is it's just reflecting off the surface of the pellet because it is solid metal. So I might try a different sample, like a powder or a just chips, aluminum or copper or something else. So these are the new samples I made. I made one like this with holmium, granulated holmium metal in it. And this is copper in here. I haven't tested the copper yet. All right, so back to, I made a little sample of aluminum, atomized aluminum powder. So that's in there right now, 0.9942 grams.
Hey, Tim.
Magnetic field at 3362.6. And I'm going to turn the microwaves on.
Just for time's sake, you can probably stop it there. So the balance readings there are on the right side of the screen. So there's really not much happening here.
So that's, according to this meter, that's 3,400 Gauss, which is higher than what it should be. I'm just doing a little bit of a sweep. No significant change in the weight. It's pulsing at 83 Hertz, which is about 6 milliseconds. 6 millisecond on time. All right, I'm just going lower. Uh, 3265. No significant change on the weight. All right, 3,200 Gauss, so I've gone quite a bit lower. I'm going to go back up to the specified value. $3,362. All right, back to 3,363. 2. Okay, I'm going to try a different sample. So that was aluminum powder. Ending at 0.989. We had a change of about 2 milligrams.
You can probably stop it there.
Wonderful. Okay, yeah, take it away, sir.
Yeah, so that's just kind of an introductory clip there. So I did try a few other samples like that. And just for thoroughness, I will put them up on my channel. But in summary, I didn't really see anything that got my attention as far as results with that. So yeah, there's a summary. So I have a few ideas on how maybe to do it differently that might get some results, and it kind of I see it relating a bit to what Jeremy was touching on there with the you know, energy, trapped electromagnetic energy. So I think maybe putting the sample just outside the waveguide, and positioning it just in the right way would create a force, rather than putting it inside the resonant cavity there, because it's like there's symmetry, right? So the microwaves they're interacting with the sample in all different directions at the same time. So there's no asymmetry. So I don't think there'd be any force as a result. So those are my concluding thoughts, you know, in summary on that. As far as, yeah. What?
Oh,
Go ahead.
and I was going to say, at some point, we're going to have to give you a giant applause. That video was awesome, Wayne. That was an awesome video. That was.
It seemed a little bit boring, but you know, I'll admit that. But it's, you know, science is there's a lot of you know, long hours staring at screens and data, and yeah, but so hey, but yeah, I appreciate the sentiments there. Thanks.
Yeah, absolutely. Well, yeah. Was that everything, or did you have more? I didn't mean to interrupt you.
Well, I'm going to put more up on my channel over the next few days. So if people want to, you know, follow up on it and stuff, they can. If they subscribe, hit the notification bell and all that good stuff.
Yeah, and actually, Wayne, can you drop that? Just drop your channel, drop a link into chat.
Yeah.
Yeah, and then I will put a blog up on the website too. I'll put a post up with all these channels and more information and stuff like that.
Okay, awesome. Yeah, it was like I spent actually like a couple, well, like 2 or 3 hours there playing with dials and samples. And I have done, I've tried to do Alzofon experiments at home and stuff like that with more, I didn't have the level of equipment Mark has acquired. So that was important for me to be able to go there and play around with that and see, you know, if there's going to be any difference, you know, in terms of his setup and what I've played with. I will say that in my experiments, which are, they're not technically not Alzofon experiments, but they are similar in that I'm trying to achieve I'm trying to achieve EPR, or dynamic nuclear orientation. And I did see small movements in some of the samples. And almost as if there's like a force being developed there, related to the magnetic field and the resonant frequency of, you know, based on the 28.025 gigahertz per Tesla relationship there. So I think there's something to that, but I don't think the way we had it set up there in the waveguide is gonna produce anything that we can, you know, observe. So yeah, that's about it.
Wonderful. Okay, well, Wayne, let me do this then. I want to put this in gallery mode. Everybody, please give Wayne an enormous applause. Please give Wayne an enormous applause. Thank you. And I see Gerald there in the corner. Maybe I could pester Gerald to do a demo. Gerald, do you think you're up for it today, or? Oh, you know what? Sorry.
Gerald, you gotta unmute yourself.
Oh, he doesn't have okay, he doesn't have audio. No, he does have audio. Okay, for some reason it's not working. Okay, well, let me see. Maybe I could go back to, let me see if Mark is set, and if not, Bernie actually had something to share as well. But Bernie, let me let me see if Mark is